We start by defining a structure and giving it a structure type name. We can then add variables of different data types inside the structure. The data types don't have to be the same, but this ability provides us with a way of holding different data types together. Keep in mind that the structure isn't declared, so the memory for it is yet to be reserved. When we declare a structure variable, memory space is reserved for the members in the structure. Normally, the structure is expected to take up as much space as the sum of the bytes of each member in the structure. But if the members in the structure are placed poorly, structure will take up more bytes in memory than it should be taking. The compiler will usually add extra bytes that fill up the empty space. This is called structure padding. The downside of structure padding is that it takes up extra memory space. One way of leaving fewer of these spaces empty is to place the variables in a way that is tightly packed without any unnecessary empty bytes laying around. This is called structure reordering. These approaches help the CPU access the data inside the structure faster by reducing the read cycles. But sometimes, when the memory space is tight, structure padding might end up causing problems. In these cases, developers may decide to disable the padding and just squash all the bytes together. This is called structure packing. It sacrifices some speed for the memory space. To access the data inside a structure, we must first declare a variable of that structure type. After declaring the structure variable, we can then access the members stored inside it. For that, we write the struct variable's name, followed by the dot operator and the member's name. Putting it simply, the dot operator lets us directly select and grab a specific piece of data from inside the struct. After accessing the members inside the structure variable, we can play with them as if they are any other variable. Structures are especially useful when we need to manage large amounts of related data. For example, if we have 100 people in a class, we can think of each person's information as a structure. But creating 100 separate structure variables manually takes tremendous effort. Instead, we can create a single array that holds 100 of these structures. This makes life easier and will allow us to organize large amounts of data under one name and easily loop through them. We can pass structures into functions in two ways. One way is pass by value. Passing by value is safer because it keeps the original data unmodified. However, it is performance heavy since the memory for the structure variable has to be copied for the usage. To keep things simple, let's step away from the array of structures and focus on just one. We can show how pass by value works by modifying a member variable inside the function and printing the result. Because we passed it by value, the original variable remains as it is. If we print the value inside the function and then print the original value afterwards, we will see two different outputs. The other way of passing structures into functions is pass by reference. When passing by reference, we pass the memory address of the structure variable into the function. In this case, the structure isn't copied and only the beginning address of the structure is passed. This makes the pass by reference approach more performance friendly. Although it doesn't really matter, I'll change the parameter to something other than mcopy to make the concept a bit more clear. When we pass structure variable by reference, we have to use it as a pointer. But writing the pointer notation every time gets very tiring, especially because of the parentheses we have to open every time due to operator precedence. Fortunately, there is the arrow operator that simplifies the pointer notation for the structures. The arrow notation simplifies the parenthesis star dot into an arrow that comes after the pointer to the structure variable, and it is very convenient. Using the arrow operator, we can edit the member variables for the structure from the function, similar to the way we did in main, merely using the arrow instead of the dot. And if we run this now, you will see that we get two identical outputs. And that is a good chunk of things you need to know about structures in C. Thanks for watching. Don't forget to like and subscribe if you liked the tutorial. These videos take a lot of time and effort, so I need some motivation to record more and better. Then I'll see you in the next one.